In this lesson, we shall look at this geometry question below, Euclidean geometry. In the diagram below, A, B, and D, C are chords. A, B, D, C are chords of a circle. E is a point on AB. Here is E, it is a point on AB, such that BCDE is a parallelogram. Opposite sides are equal and parallel. Those are properties of a parallelogram. The angle DEB is 108 degrees. DEB, this angle is 108 degrees. DAE is 2x plus 40, like this. We need to find the size of the angle X. Right, obviously we were brainstorming on this, but we know something about parallelograms. What do we know? That this angle C will also be 108 degrees. 108 degrees. Why is this angle 108 degrees? It is 108 degrees because of the fact that these are opposite angles of a parallelogram. So if you have opposite angles of a parallelogram, these angles are equal to each other. So C is 108 degrees. These are exactly opposite angles of parallelogram. So yeah, 108, 108. Next, we have 2x plus 40 degrees plus 108 degrees. If you add these two, the result is 180 degrees. Okay, if you add these, and that is 180 degrees. And this is because of the property we have that the opposite angles of a cyclic quadrilateral. Right, if we have a cyclic quad or a quadrilateral whose vertices are on the circumference of a circle, then it is said to be such that the opposite angles are supplementary. Angle A and angle B, a C, then a D, in that manner. So you have that the angle A plus the angle C must always be 180 degrees. What is the reason for this? Because these are the opposite angles of cyclic quad. Opposite angles of cyclic quad. Like so. So right now you add these two, you get 180 degrees. These are opposite angles of cyclic quad. Cyclic quadrilateral. Short for quadrilateral is quad. Okay, what is this here? 2x equals 180 degrees. Now, why are the 40 plus 108 degrees, they together give us 148 degrees. And if you subtract these two, what do you get? What do you get? You get actually a 32 degrees. You get a 32 degrees. You divide both left and right by 2. And if you divide both left and right by 2, you have x equals 16 degrees. X equals 16 degrees. Okay, they said here, calculate, giving reasons, the value of x. And we know the value of x is actually equal to exactly 16 degrees. Next question. Next question. The next question is this one here. In the diagram below, EO bisects. Okay, so we have we have EO, right? EO bisects side AC. Side AC of triangle ACE. Triangle A. Right, C. Like so, E. Okay, so we can really see that EO bisects because this length here is equal to this length there. Right, EDO is produced to be Then we have that, right, EDO is produced to be such that BO is equal to OD. BO equals OD. AD and CD are produced meet at EC, meet EC. Okay, let's look at AD. Here is AD and CD. AD and CD produced meet EC, meet EC and EA, EC, EA at G and F respectively. Okay, we're able to see the G and the F respectively. Give the reason why ABCD is a parallelogram. A, this one. Right, B, this one. C, this one. D, this one. A, B, C, D. Give a reason why ABCD is a parallelogram. Anyone who knows why this is the case? Why is this a parallelogram? Right. It's obvious. The answer to 9.1 is to say ABCD is a parallelogram. The reason is that these diagonals bisect each other. The diagonals, right, so we write like that. And we say the diagonals, so we can say the diargs like this to mean diagonals. Diagonals of quad bisect each other. Diagonals of quad bisect each other. And this is it. Okay, ABCD is a parallelogram. So ABCD is a parallelogram. So the diagonals of quad bisect each other. The diagonals of quad bisect each other. That is why, because how do they bisect each other? This bit and this bit. So this equals this. This equals that. So the diagonals of quad bisect each other. Next, we look at 9.2. 9.2 is next. Write down with two reasons, but two reasons, two ratios equal to ED over DB. E here, D here, B here. Oh, yeah. So write down with reasons, two ratios each equal to ED over DB. ED over DB. Write down with reasons, two ratios each equal to ED over DB. Right, let us have this particular question. Who can answer that question there? So let us look at this. Because you already know that the ABCD is a parallelogram, it means that this is parallel to this, and also this is parallel to this. And that is enough to bring us some good results, because if we are to be looking at the ED, right, ED, DB. Right, so yeah, we're looking at the ED here and the DB here. Okay, ED, DB. ED, DB. Right, so now we look at this and we want to actually be in a position to find what we need. And then now we can look at other things, for example, you can see that this one is parallel to here, so you can extend like this. Right, so that this triangle here has the proportionality theorem result. So if you have a triangle like this, you remember that there's a triangle like this that you need to learn. You need to know this triangle. So if this is A, B, C, D, E, then you have AD over DB is equal to AE over EC. Okay, why? Proportionality theorem. DE parallel to BC. Okay, y'all. So in the end, we have the following. 9.2, we have that ED over DB. Right, ED over DB. ED over DB is equal to FE. Right, it's equal to FE. It's equal to FE, because we're speaking about ED over DB is equal to FE over AF. And the reason for that is this is called, here we just say proportionality theorem. Just say proportionality theorem. So that's what we're going to say here. We're going to say proportionality theorem, because we're able to see that ED over DB then is equal to FE over AF, which is the proportionality theorem. Proportionality theorem. So this is what we have. So that in the end, then now you have ED over DB. ED over DB can also be equal to what? Okay, because you already have this one is parallel to this. So you have this here, this shape here, and you have this here. So this is parallel to this, which means that ED over DB is equal to, like, GE, you can say. GE over CG. And this is what we call the proportionality theorem. This is the proportionality theorem. This is the proportionality theorem. Next question. So we are to, in 9.2, we're to write down with the reasons 2 ratios each equal to ED over DB. And the ratios are that are equal to ED over DB, 2 of them. FE over AF, the other one is GE over CG, and it's the proportionality. It is this theorem, guys, this theorem here, that says that at this point, AD over DB is equal to AE over EC, as long as these two lines are parallel, as long as DE is parallel to BC. So this is what you need to realize, okay? And this is what you need to learn. And this is the highest level of geometry you'll ever meet in the school curriculum. So please learn this. Learn this here. And this is about similarity and proportionality. Now, let us look at the next stuff. Let us look at the next stuff. Right, to look at the next things, we proceed as follows. We proceed as follows. Right, we proceed as follows. Okay, next we need to look at 9.3 now. Prove that A1 is equal to F2. Prove that 9.3, we need to prove that angle A1 is equal to angle F2. Where is the angle A1? It is this one here. Prove that the angle A1 is equal to angle F2. Prove that the angle A1 is equal to the angle F2. Prove that one. So how do you prove that? How do you prove that? Anyone? Who is here? Anybody home? Anyone home? Anybody home? Anybody home? Who can want to prove that angle A1 is equal to the angle F2? So we need to prove this one. Let us prove this. It's very, very easy. Very, very straightforward. Right, to prove that angle A1 is equal to the angle F2, we proceed as follows. We proceed as follows. Right. So we start by saying FE, right, FE over AF is equal to GE over CG. And why? It has been proved. FE over AF is equal to, right, is equal to GE over CG. This has been proved already. So just say proved. And because of this, we are able to say, therefore, AC is parallel to, FG. AC is parallel to FG. Why? Line divides two sides of triangle in proportion. This is the reason. Line divides two sides of triangle in proportion. And this is the reason. Okay, so we proceed. Line divides two sides of triangle in proportion. And this is the reason. Right. Now, as a consequence, we're able to see, therefore, that if AC is parallel to FG, these are parallel to each other. Angle C2 is equal to the angle F2. C2 is equal to the angle F2. Why? Because these now are alternate angles. How beautiful is this? The angle C2 equals the angle F2, and the reason for this is these are actually alternate angles. Right, they're alternate angles. Now, because they're alternate angles with AC parallel to FG. With AC parallel to FG. So that in the end, then what you have here, the angle A1, is equal to the angle C2. The angle A1 is equal to the angle C2. Why is the angle A1 equals the angle C2? Right, so this angle here, A1, is equals to the angle C2, so you're seeing a Z. You're seeing a Z, and the reason is that these are alternate angles. Why are they alternate angles? They're alternate angles because AB is parallel to CD. AB is parallel to CD. C2 is F2, angles. Angle A1 is the angle C2. As a consequence, we're able to conclude, therefore, that the angle A1 is equal to the angle F2. The angle A1 equals the angle F2, and this is what we're able to observe. The angle A1 equals the angle F2 here. And we have been able to deduce that. Here's the question that was asked, and this is what the students had to do. Some of these questions might not look so obvious to prove, and having to prove that angle A1 is equal to angle F2. Now, I'm going to send you homework, guys. When I send you the homework, you try the homework. You don't sleep on the homework. You do this homework, but you must watch the videos. Every homework is connected to the videos. That is step one, okay? So that you do not get confused with these things. Next point. We want to prove 9.4. 9.4. Hello, 9.4. It is further given that ABCD is a rhombus. Rhombus means that the opposite sides are parallel and equal to each other. All the sides are equal and the opposite ones are parallel. Okay, so this is a rhombus. But moreover, the diagonals bisect each other at right angles. Okay, so this is our story. And we want to prove something. We want to prove that ACGF is a cyclic quadrilateral. A, C, G, F is a cyclic quad. A, C, G, F is a cyclic quadrilateral. Let's do this one. 9.4. Angle A1 is equal to what? First things first. Right. The angle A1, to prove that AC GF is a cyclic quad. For vertex shape is a cyclic quad. So we want to prove that the angle A, we first note that the angle A1 is equal to the angle A2. The angle A1 equals the angle A2. Why is A1 equals A2? These are diagonals. Diagonals of rhombus. Diagonals of rhombus. So A1 equals A2. The diagonals of a rhombus, they do this. So this diagonal is going to cut this angle into two equal parts, and it's going to cut these like that. So these are the diagonals of a what? Of a rhombus. Okay. So yeah, these are the things you need to know. The angle A2 about a rhombus. The angle A2 equals the angle F2. Angle A2 equals the angle F2. Why? Why is angle A2 equals the angle F2? Right. The angle A2 equals the angle F2. The reason for that is that angle A1, we already have established this. The angle A1 is equal to the angle F2. We already know that A1 is F2, but A1 is A2. So that, or we can even say, yeah, it's, can write it like that, but yeah, I can also write it like this. Can also write it like this. A1 is A2, diagonals of a rhombus. And then you can come and say, but the angle A1 is equal to the angle F2. Why is the angle A1 equals the angle F2? Angle A1 equals the angle F2. Why? Why? Angle A1 equals the angle F2. Why? Because it was proved. Proved in 9.3 above. Okay, sorry, yeah, this A1 equals F2, it was proved in 9.3 above, and then we are in business to say therefore. And this is pretty nice. It's a nice proof. Very nice proof. Therefore, A1 equals A2 and A1 equals F2. That means therefore this means therefore the angle A1 equals the angle, or rather the angle A2. The angle A2 is equal to the angle F2. So we've proven the angle A2 equals the angle F2. Look at this. This is like a bow tie, this. Bow tie shape. Aha, bow tie. There's no circle around it, but yeah, it follows those properties. Hey, we're going deeper into geometry, and you need to make sure you are concentrate. We need your maximum attention. Attention. Right, because now we have the angles in a bow tie. These angles are equal to each other. This here equals that angle there. Hey, what then is this? This is our story. And we say, therefore, ACGF equals what? Right. ACGF is a cyclic quad. Why is it a cyclic quad? It is a cyclic quad because we can see angles in the same segment. We're able to see angles in the same segment equal. We're able to see angles in the same segment equal. And this is our story. So we have been able, but most importantly, we have been able to establish that the ACGF is a cyclic quadrilateral because the angles in the same segment are equal to each other. Okay, next thing. The next thing. Next question. Here comes a question. Here comes a question. How do we prove the first point? In the diagram below, triangle ABC and triangle PQR are given with angle A equals angle P, angle B equals angle Q, angle C equals angle R. DE is drawn such that AD is equal to PQ, and also AE is equal to PR here. Next, so we want to establish, we want to prove something. Right, we need to prove that triangle ADE is actually congruent. Right. Right. Triangle ADE is congruent to triangle PQR. 2 marks. 2 marks. Right, let us look at this particular question here. Let us look at this particular question. How do we prove this with ease? Right. Right. Right, so we continue. We continue. So now to prove this one here is grade 10. This sign that is like these 3 lines that line down like an equal sign. Right, so these 3 lines that are lying down, they mean congruent. They mean congruent. So now we congruent triangles. Yes, please. Okay, that's fine if there's no question. So yeah, we just want to do 10.1.1. We are back to grade 10. This one is grade 10. This sign that is lying down like this is a grade 10 sign. Right, so we continue. We continue. This is a grade 10 sign. We continue. We continue. We proceed with ease. We proceed with ease. Yes, please, Sanulu.
It's Tando.
Oh, Tando. Sorry, Tando. Yes, please welcome, Tando.
I think the answer is side angle side.
Well done. It is side angle side. Brilliant. Thank you so much. Well done. Excellent. I like it. I like it that way. Yeah, so we're on point. It is side angle side. And we're going to now to prove 10.1.1. We're going to say in triangle. Right, in triangle ADE. You are right, Tando. And triangle PQR. Then you'd have that AD is equal to PQ, which is construction. Right, so right, so we continue to answer these questions, and I say Tando is on point, and they were back to grade 10, and I know that Tando, I can see that Tando remembers the grade 10 work on the geometry, and so this is what makes us happy people. We are happy people. We are very, very excited people. So this is our story. Okay, we continue to establish the results. So we need, yeah, it's side angle side, I agree. So first we know that AD equals PQ, but also we know that the angle A is equal to the angle P here. Angle A equals angle P. So you have that the angle A is equals to the angle P. And the reason for this is that it was just given that way. So, right, so we continue. Right. Right. So now we also have that another side, because now we're taking the side, then we took the angle, then we take another side, and the side here is the side AE. And this side AE is equal to PR. And the reason for this, it is a construction. Construction. Therefore, triangle. Right, therefore we have the following triangle. Right. Therefore we have the following triangle. Therefore we have that triangle ADE is congruent to triangle PQR. Right, so triangle ADE is congruent to triangle PQR. And as Tando said, this is about the side, angle, side. Side, angle, side. This is AD equals PQR, PQ are sides. Angle A equals angle P are angles. AE equals PR are sides. And it's side, angle, side, and the triangles are congruent triangles. Next point. Okay, want to prove 10.1.2. Prove that DE is parallel to BC. DE is parallel to BC. How do you prove that DE is parallel to BC? We proceed as follows. DE is parallel to BC. Let's prove this one. Anyone home? This is too easy. To prove that DE is parallel to BC, we then say, right, angle ADE. ADE, this angle here, is equals to the angle Q. Is equals to the angle Q. Why is this the case? Right. These are triangles congruent. Triangles congruent. Triangles congruent. Moreover, we say, therefore, corresponding angles equal. Right, so we continue. Right, so we have the following. We have the following over here. Right, we have the following point. We have the following point. Right. Now, we want to establish this result here. All right, so we continue. But, okay, we said ADE is equal to the angle Q, but angle B is equal to Q. Angle B is equal to Q. Angle B equals Q. Why is angle B equals Q? Right, angle B equals Q. Why? Because it was given that angle B equals Q. It was given. Therefore, triangle ADE, or angle ADE, right, angle ADE is equals to angle B. Well, angle ADE is Q. ADE, this angle is equal to Q. Because we have triangles congruent, therefore corresponding angles equal. But angle B is equal to Q. B equals Q given. Therefore, angle ADE is equals to angle B. Therefore, DE is parallel to BC. Therefore, DE is parallel to BC. Why is DE parallel to BC? Right, so now you have that this angle ADE is equals to this angle is equals to this angle. And these things here, they are from grade 10. From grade 10, we have these angles like that to this. If you have this, what is this? This equals this. What is this? These are corresponding angles. Corresponding angles equal. Corresponding angles equal this equals this. Corresponding angles equal. Corresponding angles equal. Because this is equal to this. It means, therefore, DE is parallel to BC, which is what is to be shown here. Right. Because this angle is equal to this, like those angles in F like this. Okay, if you have angles in F like this, if this angle equals this angle, it means these lines are parallel. And conversely, if these two lines are parallel, then the angles are actually equal to each other. Okay, now we have proven that DE is parallel to BC. I'm going to send you homework. When I send you the homework, please, you try the homework. But also, you watch the videos and then try the homework, because the homework is always linked to the videos. But always, we continue to crack more mathematics. Next point. Next point. 10.1.3. 10.1.3. Hence prove that AB, okay, here is AB, over PQ is equal to AC over PR. Right, so AB, now we start by saying AB over AD. AB over AD is equal to AC over AE. This is the proportionality theorem. Proportionality theorem. But AD is equals to PQ. But AD is equal to PQ. Okay, by the proportionality theorem, we know very well that AB over AD is equal to AC over, okay, because these things are parallel. Okay, if these two lines are parallel, then you can just write and say, okay, this is parallel to this. So we can say AB over AD is equal to AC over AE, and this is the proportionality theorem. Right, so we continue. Proportionality theorem. Okay. But now we have AD over AB over AD is equal to AC over AE. Proportionality theorem. Good. But Mr. Examiner, we already know, according to these two things here, we already know that AD is equal to PQ, because they wrote it here. AD is equal to PQ, but they also said that AE is equal to PR. Therefore, AB over the AD is PQ. And AC over the AE is PR. And it is exactly this. So we've proven this one, because you have to prove that AB over... Okay, remember, we are going full power into geometry. Full power into geometry. So this is not a joke. We are going full power, full strength, and therefore we need to make sure that we make the most of our time in the learning of geometry, and we become the best we can be. Highest level of geometry is what we have. Right, so we continue. Right, so we continue. Next point. Right, the next thing is, in the diagram below, VR is the diameter of a circle. Here is V and here is R. VR is the diameter of a circle with center O. S is any point on the circumference. S is any point on the circumference. P is the midpoint of RS. P, here is P. It is the midpoint of RS. Now P is out in the middle. The circle with RS is the diameter. Here is this circle here. With RS is the diameter. So if this RS is the diameter, it subtends an angle of 90 degrees at circumference. So this diameter will subtend an angle of 90 degrees. That is what we know. But also, now this one, VR, is also a diameter. If this diameter is going to subtend an angle of 90 degrees there as well at circumference. Okay. The second RS is diameter. Cut VR at T. Cut VR at what? At T. ST. ST. Here. STOP. STOP. And SV are drawn. Right. So we have that ST, OP, and SV are drawn. Here's the exam question. Why is OP perpendicular to PS? OP perpendicular to PS. Why? Too easy. Why? Tando, Sanulo, any one of you, too easy question. Too easy question. Why is OP perpendicular to PS? Why? Anyone, please?
Subtended by diameter, so I'm only going to say my circle.
Okay, you're on point. You are on point. Okay, yeah, but thank you so much for that feedback there. I think that, right. There is a theorem we do at grade 11. The theorem says this. It's theorem 1b or theorem 2. If you have this, because now there's a line from the center, but it bisects this chord here. So line from the center that bisects the chord. If this happens at grade 11, we already know something. This means that we have this perpendicularity. Okay, so this is very important for us. This means perpendicularity. So this is what happens. So because we have a line from the center that bisects the chord, it means it is perpendicular to the chord, like that. That is why these examiners ask you a question, because of that theorem. So now the reason in 10.2.1 that the student is expected to state is about line from center to midpoint of chord is perpendicular to the chord. As long as you have a line from the center to the midpoint, so that this part equals this, then it is perpendicular to the chord. So we then say line from center to midpoint of chord. Line from center to midpoint of chord. That is the reason. Line from center to midpoint, because this is the midpoint. They even use the word midpoint. The examiner used that. P is here. P is the midpoint of RS. P is the midpoint of RS. So if P is the midpoint of RS, P is the midpoint of RS. And therefore, because P is the midpoint of RS, it then means, therefore, that the midpoint produces perpendicularity. And also, this is true. If this is perpendicular, then you have a midpoint. This becomes the midpoint. Okay, this becomes the midpoint. So, okay, these are the things you need to learn. Let's look at the next question. Prove that triangle ROP is equal to triangle RVS. Prove that triangle ROP is equal to triangle RVS. Right, so let us do this one. What do we do here? What do we do here? Okay, let us look at question 10.2.2. Right, so prove that triangle ROP, ROP is similar to triangle RVS, to triangle RVS. Yeah, this is similarity now. It's vertical. Similarity. Similarity means that we need to prove equiangularity. We must prove that these angles are all this angle equals this angle equals this angle equals that. Okay, so let us look at that one. So now we have that first things first. To prove that ROP is similar to triangle RVS, So you first note that OP this one is actually parallel to VS. OP is parallel to VS. Why? Because of the midpoint. Midpoint theorem. Midpoint theorem. Right. So in other words, the midpoint theorem, what does the midpoint theorem is from grade 10, this. What does the midpoint theorem say? The midpoint theorem is about the midpoints. Okay, hope your teacher covered that in grade 10, but midpoint means that this is equal to this. And also this is equal to this. So that this is like the midpoint of the side because this bit is equal to this bit. But this is also the midpoint of the side because this bit equals that bit. And therefore, if these are like the midpoints, then we know very well from grade 10 that if this is A, B, C, D, E, then DE is parallel to BC. This is called the midpoint theorem because you already know that P is the midpoint. Here the examiner said it because they wanted to take your mind to grade 10. We are not at grade 10 anymore, but some of the results are from there. Right, like your P is the midpoint, right? If this is the case, but also O is the center. If O is the center, then you have a radius. If you have a radius, it means therefore that this here is equal to this bit here because the distance from the center to the circumference is equal to the distance from the center to the circumference. It's a radius and radius. So radii are equal to each other of the same circle. Radii of the same circle are equal to each other. Okay, we are in business now. Let us go on. So we go on to say, Mr. Examiner, in triangle ROP and triangle RVS. Okay, let us look at those angles and triangles. Triangle ROP and triangle RVS. First, the angle R is equals to the angle R. The angle R equals the angle R. Why? Because we have common angle. Common angle. Common angle. Okay, good. Because why is it a common angle? We're dealing with triangle ROP, which has R in it, and angle R triangle RVS, it has angle R in it. So that now we have also angle O2. Angle O2 is equals to angle V. Angle O2 is equals to angle V. Angle O2 is equals to angle V, which means that you have corresponding angles. Why do we have that O2? These are corresponding angles because you already have that this is parallel to this. So that O2 is equal to angle V, and these are corresponding angles. Why? Because you corresponding angles every time when you have corresponding angles, always tell the examiner which lines are parallel to each other. So we have that OP is parallel to VS. OP is parallel to VS. Therefore, triangle ROP is similar to triangle RVS. Why? Angle, angle, angle. Angle, angle, angle. Good. So yeah, we actually are in business. We are in business. So we have angle, angle, angle. We have angle, angle, angle. Angle, angle, angle. So this is what we have. This is what we have. Okay, so we have those particular angles there. So we've seen that angle O2 is equal to V. Angle R is equal to angle R, but we can also state this one here. We can also state, you can just put a little bit more. Because, okay, somebody's going to say, but you mentioned 2 points. These are like 2 points because you have said this one here is equal to this one here is equal to that one there. So which means that angle P2 is equal to this angle here. So that angle P2 is equal to angle S. Angle P2 is equal to the whole of angle S. Okay, yeah, you can say angle S, but you can also say RSV. Okay, just to state this angle, doesn't matter what you say, but you can say RSV. So that angle RSV, okay, this is geometry, folks. So it's not a joke. You need to quite open your eyes. So right now, angle P2 is equal to angle RSV. And why is this? Why are these angles equal to each other? Because we already said this one is an angle in semicircle, but also this angle P2 came down to 90 degrees earlier, so that we're able to say that these angles are equal and equal to 90 degrees. Okay. Right. So yeah, you can say that also equal 90 degrees. Or you can say this angle P2 equals the angle RSV. Why? They're both equal to 90 degrees. Both equal to 90 degrees. So that in the end, we have the P2 in that. And therefore, triangle ROP is similar to triangle RVS. Why? Because angle, angle, angle. Right, so angle, angle, angle is the result. And we know that, okay? This is very important. We have 3 points. If you look at the angle ROP, angle RVS, you have the angle R equals angle R, O2 equals V, P2 equals S, or equals the angle RSV, so that we have that these are both equal to 90 degrees, and therefore these 2 triangles are similar to each other. Next point, we proceed now to look at the next result. What is the next result? Want to prove this one here. 10 points. We have 10.2.4, and now we need to understand this and establish this result over here. Okay, so let us prove this one here. First things first, 10.2.4. 10.2.4, we are required to prove that, so required to prove. Into 10.2.4, we're required to prove that st squared is equal to vt dot tr. Okay, so this is what we have. This is what we have. So in other words, we have that st squared is equal to vt dot tr. Okay. Now, to do this, first things first, this is a bit tricky all the time, but you need to always break it down to this. So st squared is like st times st is equal to vt times tr. So that with st over, right, so you change this, you convert it a little bit. Right, so you convert it to some proportion. So if you convert it to some proportion, then you're going to say, for example, st over, so you can take any of this. For instance, if you take st over tr is equal to st vt, or you take st over vt, you can divide by vt here, so that it is equal to tr over st. Let us look at these very carefully. You're converting this to that. And then now you are looking at, for instance, if you're to say, for example, ST over TR. Here is ST, right? And then now you take ST over TR. This is TR. And then now you have VT over ST. Or you take ST over VT is equal to TR over ST. Anyway, in either case, you can see that we're going to work in triangle RTS and triangle STV. Triangle RTS and triangle STV. That's what this one boils down to. But first things first, we're going to note that we have that the angle RTS, angle RTS is equal to, right, the angle RTS, this one here, is equal to the angle VTS, which is equal to 90 degrees. Hello? Okay, thank you, microwave, my dear. Okay, thank you, my dear. Right, so you have the angle RTS, which is equal to the angle VTS, right, which is equal to 90 degrees. So you're able to see that this is true. Why is this true? Because of the following thing. Because obviously, I mean, you already know that this is 90 degrees and that is 90 degrees. The reason why they're both 90, because already you know that P is the midpoint, etc. And you have heard this, but also you were told a couple of things, that RS is the diameter. If this RS is the diameter, it subtends an angle of 90 degrees. If this one is 90 and that one must be 90, because they are adjacent angles on a straight line. So these are angles on straight line. These are angles on straight line, right? So that in the end, what you have is now the angle R, right? We have moreover that the angle R, which is this one here, the angle R, which is this one here, is equal to 90 degrees minus the angle TSR. The angle R equals 90 degrees minus TSR. Okay, these are the angles in a triangle. Angles in a triangle. These are angles in triangle. Well, you see, the thing is that this one is already 90. So this one plus this one must also be 90, so that you get 180. So that we say angle R is 90 minus TSR. So that in the end, then you have TSV. TSV. Right, the angle TSV is equal to, so in other words, we have that the angle R is equals to the angle TSV. Let us look at these very carefully so that we see that the angle R and the angle TSV. Right, right. So pay particular attention to this level of detail here and think about what is happening in this case. Right, so if you see that this angle here, the angle R is 90 degrees minus TSR. Okay, and then also, now that angle here is equal to the angle R. 90 degrees minus TSR is angle R. But now, what is the size, therefore, of the angle TSV. TSV. This angle here. This angle here. What is the size of this angle there? Because you already know that this is parallel to this. That you already know. That OP is parallel to, okay, we know that OP is parallel to PS. OP, right, is actually very much parallel to PS, or is perpendicular rather, right? OP is perpendicular to PS, so that this angle is actually 90 degrees there. And you already know that this one is the diameter, so it obtains an angle of 90 degrees there. So this is 90 and that is 90, and these are parallel to each other. Right. And moreover, we're able to see, therefore, that angle R now, this angle R is 90 degrees minus TSR. Okay, I'm trying to bring that to this point, that now the angle R is equal to angle TSV. Look at that, but look at that very carefully. That the angle R is equal to the angle R is equal to TSV. Is this angle here? You see, this is equal to this angle here. So the angle R is equal to TSV. This angle is equal to this angle there. Right. And that is true because you already know that, in other words, this angle here, angle R is 90 degrees minus TSR, but also this angle here is 90 degrees minus TSR. This angle here is the whole 90 degrees minus TSR. Okay, so that TSV is equal to angle R. Okay, note that one. Let us continue. Moreover, we're able to see that the angle TSR, the angle TSR is equals to angle V. The angle TSR is equals to angle V. The angle TSR is equals to angle V. Right, so we continue. Right. Right. Okay, so we continue. We continue. We continue. Yeah, let's just write this one here. So that the angle TSR, the angle TSR, right, TSR is equals to angle V. The angle TSR is equals to angle V. Okay, so the angle T S R is equals to angle V. Okay, look at that and look at that very, very carefully and note that. And if that is the case, we're able to see that triangle RTS is actually similar to triangle STV. Angle, angle, angle. Okay, because now you have that, you have written three things. You have written three statements, basically. And therefore, you achieve that the triangles are similar. Okay, so we continue now. Okay, you ask if you have a question, please. You ask if you have a question, but now we're able to write a conclusion. So we move from here to there. When you get to this part, we have this here. Okay, because we have this means that RT over ST, RT over ST is TS over TV or VT. RT over ST, RT over ST is TS over VT. Okay, you choose, remember I said that last time. Here you choose right, obviously we take the RT over ST, and then RT over ST is equal to TS over VT. And we get this. And then now we cross multiply these things. And if you cross multiply these things, this is like ST. You can write it as the RT. Okay, you can write it as the, you can write this one as ST over VT is equal to TR over, okay, so we're just starting to write it from the right. So is the ST over VT equals TR over ST. And therefore, if you cross multiply this, which is ST squared. If you cross multiply ST times ST, it's ST squared equals VT times TR. VT times TR. Right, so we've proven this, and it's way, way too easy. Right, we have proven this, and it's way too easy. Right, I must thank you guys for joining us this afternoon, but I'm going to see you guys again at 8 p.m. Right, we're going to meet again at 8 p.m. to do science, both science and math. We're going to see which one to do. Or both, you know.